It works on my machine. It's a common refrain before closing out a bug ticket, but this hides the fact that there's something different between your development and production environments. There are a bunch of ways to resolve this problem, but one of the easiest is to use a solution like Docker to make sure that our development environment matches our production environment as closely as possible. In this video, we'll discuss what Docker is, why you should use it, and how to get a basic development environment up and running. Hello developers, and welcome to the PHP Architect channel. If this is your first time here, my name is Scott Keck-Warren, and on this channel we discuss a wide variety of topics related to the PHP ecosystem. Make sure that you subscribe so you can get our latest videos whenever they're published. In modern kernel versions, Linux provides access to a technology known as containerization. A container is a sandbox process running on a host machine that will be completely isolated from any other process that might be running on the same machine. These containers are portable and can run on any OS, and due to its isolation, it can run its own software at specific versions with specific configurations separate from each other. Because it's just another process running on top of Linux, the overhead for this container is very small. Because it's been built in a portable fashion, these containers can run on local machines, virtual machines, and in cloud providers' infrastructure. Now, creating containers can be a little challenging, but Docker provides us the glue necessary to quickly and mostly painlessly create a container that you can use on one or more Linux-based computers. It does this by providing a set of command line tools for interfacing with the containers, as well as a file format to define our containers. What services they provide and how they interrelate can also be included in these files. Ideally, we should only be running one process at a time in each container, so we'll need to create multiple containers for each of the services we need to run our application. Now we can use a Dockerfile to define how the containers should be created, and a Docker compose.yaml file to define how the containers are related and what services they provide. We can then include these files in our source control so everyone can use them and have essentially the same setup, if not exactly the same setup. Docker also allows us to create a snapshot of our container called an image at a specific point, which we can then share with everyone. So the whole team is using the same development environment almost exactly. We can also then push this image out into our production environment to make sure there's complete matching across all environments. This allows us to cure our workflow of the works on my machine mentality. There are a couple of things that we need to discuss before we talk more about Docker and containers. The first is an image. A running container will use an isolated file system, and an image is used to provide this isolated file system. The image must contain everything necessary to run our application, including all of its dependencies, configurations, binary files, and so on. It will also contain information about the default command to run, environmental variables, and any other data we might need. This isolated file system is also reset every time the container is stopped, so any changes to the file system will be lost. This is actually a good thing because it will make it really easy to reset our application to a known good state. We can also define networks that containers will use to connect and communicate with each other. These networks will also be isolated, so you can expect them to stay mostly secure on the local machine. Finally, we need to talk about volumes, and volumes provide the ability to connect specific file system paths of the container back to the host machine. If you mount that same directory across container resets, you'll see the same file even after it's been resetted. So let's talk about how to use Docker on Linux. Docker on Linux is easy to use as long as you have a modern Linux environment. In this example, we'll be working through setting up the environment on Ubuntu 22.04 as it's the current long-term support release as of this recording. To install Docker, we just need to run apt-get update and then apt-get install docker.io and docker compose. And with that, we're done installing it on Linux. I'm also going to create a directory to store our work. So you might be saying to yourself, well, that's great, Scott, but I don't use Linux every day, so what do I do? In that case, you need to download Docker Desktop, which will provide an application you can run when you need Docker. The application will transparently spin up a virtual machine on your computer, which will then be used to host the Docker-based containers. I should warn you that because you're running the containers inside of a virtual machine, there is a performance penalty, but you might not even notice it depending on how fast your computer is. After the Docker desktop application has been installed, you'll need to have it running for the next piece of our tutorial. For our example today, we'll set up a very basic Linux, Apache, MySQL, and PHP or LAMP stack. I'm going to start out with a very basic index.php file that just outputs the PHP info. Now the first thing that we need to do is create our Apache container. We'll do this by creating a file named Dockerfile at the root of our project and edit it. Inside of this file, I'm going to write from PHP 8.3 Apache, which is telling Docker that we're going to create a container using the image PHP 8.3-Apache. And this will contain a build of Apache configured to serve files on port 80, and it already has PHP 8.3 installed. Then we're going to copy index.php to var www html index.php. Now we need to build the image using the command docker build -t php 8.3, and then we're going to specify the path of the local directory. So right now it's pulling down that 8.3 Apache image and all the pieces are there, and then it just copied over our index. Now we can run docker image ls to see the different images that are built, and we can in fact see our PHP 8.3 image. Now we're going to use docker run -p 8 or 0.0.0.0 port 80 to port 80 PHP 8.3. And this is telling Docker that we want to run an image called PHP 8.3, and we're going to make port 80 available on the host machine. And so just like that, we booted up the machine. Now I can browse the IP address of the machine that the Docker is running on, and I can actually see that it's spitting out that it's running PHP 8.3. If I go back to the command line and I can do Control-C, it will then shut down that container. So the way that we just ran our container puts the output on the terminal so we can see what is happening to the container. But it's not the best way to run it if we want to keep that container running. We can get around this by running the container in the background using the D or detached command line switch. This will output a string that is the container ID. If we want to stop the container, we can run docker container stop, and then the beginning of this string. And that will shut it down. We will have more about Docker after this word from our sponsors. PhpStorm is a cutting-edge IDE tailored specifically for PHP and web developers. If you haven't used it before, or it's been a while since you've last tried it, now is the perfect time to check it out. PhpStorm has recently received significant performance enhancements and has an ever-expanding feature set. I'm a recent convert to PhpStorm, and I love it. One of my favorite features is the ability to search across the entire codebase for a class or a function name, and then just jump right to it. Curious to see if it's the right fit for you? Head over to jetbrains.com/phpstorm to learn more and try it out with a free 30-day trial. Code smarter, not harder. So let's alter our container so we can actually do some development work in it. To do this, I'm going to change the Docker file so we install Vim so we can alter the files. I'm going to do run apt-get update and apt-get install yes Vim. And then I'm going to rebuild the container and then rerun it again. So now I have a new image running that has PHP 8.3 and Vim, so we can try to make some changes. To access the container, I'm going to use docker exec-it and then the beginning of the container ID. Oops, and then /bin/bash to open up a bash prompt. So now I'm inside the container. I'm going to edit the index.php file.
I'm going to change it so it says echo and then my name. And then I'm going to exit. So now if I go back to my browser and I refresh, it says my name. So we made a change inside the container to a file inside the container. And if I exit the bash prompt and then I do docker stop and then D25B, that should be enough. It's going to stop that one, and then we're going to rerun it again. And it's back up and running. But now when I refresh the page, my work is gone. That's how far we are away from messing up our environment and then just restarting it to a last known good state. But how do we actually work on something so that the code doesn't reset? And the solution to this is to set up a volume so we can edit the files outside of the container and have them be saved. To start, I'm going to create a docker compose.yaml file. And then I'm going to say that this is version 3. And we're going to say the services that we need are web. And in order to build web, we're going to work in the context of the current directory. And the Docker file is called Dockerfile. And we're also going to say that we need ports, $apt app port 80 goes to port 80.
Now, using app port :-80 is a little bit of an overkill for this project, but this will allow us to set an environment variable that we can then use to override the port that will access the Docker container. To keep it more simple, you could just do 80:80.
And then we also are going to define a volume of the current directory goes to var www html. Now I'm going to run docker compose up dash detached. Oh, and I misspelled port. Actually, while I'm in here, I did volumes wrong too. So this is ES. Oops. Ports. Volumes. Okay, I think that's right now. Let's try that. Okay, there we go. So if we go back over to our browser, we still have access to our PHP info dump. But now what we can do on the host is I can do vim index.php. And I can change this to echo Scott Keck Warren. Get rid of that line. And we can see now that we have my name on the screen as opposed to the PHP info. And then I'm going to do docker compose down to shut down our Docker. And then docker compose up. And if we go back over to our web browser and we refresh, we still have the changes. So now we want to do some real development and get a MySQL database involved. To do this, we're going to edit our Docker compose file to include a MySQL container and then link them together using a network. So we're going to say there's a network and we're going to call it Scott's network. And then we're also going to say that this depends on MySQL, which is going to say bring up the MySQL before you bring up the web. And then now what we're going to do, we're going to go back out here and do MySQL image. So we're going to give it a specific image to run and not a Docker file. MySQL server 8.0. And then we're going to say ports. And we're going to say $forward DB port. And we're going to say 3306 goes to 3306. So that's a MySQL default port. And then we're going to do environment to define some environment variables. Oh, I missed something. Oh, I missed a single quote here. And we have a bunch here. We're going to say MySQL root password is password. MySQL root host is percent. MySQL database, and we're going to call this Scott database because I'm going to be the one doing the development work. MySQL user is Scott user. MySQL password is Scott password. And then we're also going to say MySQL allow empty password. It's going to be 1. Shouldn't do this in production, but it'll help with our development work. So this is going to set up a root password of password, and then we're going to create a database called Scott database with a user called Scott user with Scott password as access to. And then we also need to do volumes, and we're going to give it access to MySQL volume, which we're going to have to define here in a moment, goes to var lib MySQL, which will say that we have a new volume that we're going to give it, and it's going to map into the var lib MySQL directory, which is where MySQL stores all of its information, so we won't lose that when we reset the container. And then we're also going to bring it into the Scott's network. And then now, we defined all of our services. Now we need to find our networks. And we're going to say Scott's network with a driver of bridge, which will give it access to each other and the outside, but not allow people to come in directly. And then we also need to define our new volume of volumes. I am terrible at spelling volumes. Volumes, and we're going to call it MySQL volume, and driver is local. I'm going to exit out of here. We also need to alter our Dockerfile to enable the PDO MySQL extension. To do that, I'm going to get rid of Vim and add a new line that says run Docker PHP extension install and then PDO MySQL. And then lastly, before I do anything else, I'm going to quickly alter the index.php file to connect to the database. And I'm actually going to do this by removing the index file and then recreating it and pasting that in so you don't have to watch me type all of this out. The full source code for this can be found in the companion article. Okay, now we're finally ready to rebuild our image. And then we can run docker compose up. And because this is the first time we've run this with the MySQL server image, it's pulling all of that down and configuring it. Now that the output stopped, we can come back over to our web browser and see we can in fact connect to the database successfully. And just like this, we have a working LAMP stack. We could add other services like Redis or Memcache, but I'll leave that up as an exercise to you. To recap, Docker is a tool to build Linux containers. We will use a Dockerfile to define how our containers should be created, and we'll use a docker compose.yaml to define how our containers are interrelated. I hope you enjoyed our video. If so, make sure you subscribe, comment, share, and like, as it does help others find us. Are there topics you'd like to see us cover, or are there questions that you have after watching this video? Make sure you drop them in the comments section below, or message me on phpc.social, at Scott Keck Warren. I would love to help you, and I always love to hear from a fan. This is Scott Keck Warren for the PHP Architect channel signing off and reminding you to keep watching, keep coding, and keep reading.